Okay, so in this example, I'm going to look at question number 12 from page 472 of your workbook. Oops, that's a 7-2. If you've seen video 11, or I mean the video I made for question 11, this one is very similar. If not, I'll walk you through it. Now they're giving me an equation x squared minus 4x minus k divided by x plus 3 has a point of discontinuity. By saying it has a point of discontinuity, they've told me a couple of things. One, that the final graph is actually linear. And what I mean by that is it's a straight line. Points of discontinuity don't happen on curvy graphs like parabolas, for example. If there are inadmissible values on those graphs, we'll see an asymptote. We only see points of discontinuity on linear graphs. The second thing that I know about a point of discontinuity, and maybe I'll just bear with me for a second, the numerator of this equation is a quadratic, and yet by saying there's a point of discontinuity, I know something must happen to this equation to make it linear, and what must happen has to do with the denominator. So points of discontinuity happen on equations of a graph that have a denominator, and they happen at the spot where the denominator equals 0. So at some point on this graph, this value of x will make this equal 0. And so when I solve that, the point of discontinuity on this one, x cannot equal -3 because that will make this point of discontinuity. So what happens though is when we factor this equation, and I'm not going to factor it yet because I don't know how to factor it, but the way the equation becomes linear is that one of the factors in the numerator is actually going to cancel out with the denominator. So at some point I get the exact same factor in the numerator that's in the denominator. And then I get a second factor. I don't know what it is. So just to show you how I'm going to figure out what the second factor is, I want to give you an example with numbers. So here's an example. Let's say it's x plus 2 times x plus 5. When I FOIL this out, plus 5x plus 2x, okay, plus 10. Okay, when I when I FOIL it, I end up determining what the constant term is, and that's what they're really asking for. What's our constant term? So have a look at my constant term, which is a 10 with a really weird written 0. How does that constant term relate to the factor in the first bracket that I already know? How are 10 and 2 related? Okay, and more importantly, how does knowing what they are get me to the 5? Okay, so what I know is that in order to find that second factor, the one I don't know, I'm going to have to take my constant term and divide it by the number I have. That method doesn't change even if you don't know your constant term. In the equation they gave me, they told me my constant term is -k, and I need to divide that by the term I know. And in this case, the term I know is 3. So I'm not actually putting a value in there, I'm putting a placeholder to say I don't know what this number should be, but later when I know what k is, I'll be able to figure it out. Just a note, your book calls this -1/3 k. So -1/3 times k is the same as -k divided by 3. That is the same value. Okay, so next what we're going to do is we're going to FOIL out the numerator. So x times x is x squared. X times -k over 3 is -k over 3x. 3 times x is 3x, and 3 times -k over 3 is -3k over 3. What I want to focus on right now, and actually let me just erase some of my doodles here. they actually gave us a bit more information to help solve this. They told me that the central term that I have there is a negative 4x. So when I combine my two x terms, they should result in the negative 4x that I see in my equation at the top. So negative k over 3, whatever that number is, x, plus 3x should equal negative 4x. Okay, so I want to simplify this equation. The first thing I notice is that every number here has an x value on it. So it's very easy to divide every term in the equation by x. Wonderful, I got rid of that. So negative k over 3 plus 3 equals negative 4. And I'm just going to carry this up a little bit here because I ran out of room. Okay, so let's subtract 3 from both sides. Negative k over 3 equals negative 7. I multiply both sides by 3 to get rid of the denominator. Negative k equals negative 21. Divide everything by negative 1. K equals 21. So that's your answer there. Now I realize in this question they didn't give you a lot of concrete numbers to work with. So it's actually a really great question from a teacher's perspective, because what we're checking here is, do you understand the concepts of points of discontinuity? Do you know that it's going to be a linear graph? Do you know you're going to reduce something with the denominator? Even this step, do you know that your two internal terms are going to add up to the central term in your quadratic?